All right. Good evening, everyone. Once again, thank you for joining in. And today we have a special guest, right? Right. So if you okay, I think most people here attended the session we had this afternoon also. So this session we are going to be having today builds on top of that. So today we'll be teaching you guys how to build your own machine learning model. And we have our instructor on the call, Silas Osumba. So please let's welcome him. Let's welcome him. Send in your reaction. So if you did not know, Silas was the former SPE president. Some of you may not know this, right? And he was the best graduating student of last set, right? He was in the last set. So he's also an AI ML engineer too. So he will be taking you guys today. So Silas, are you there? Are you ready?
Yeah, I'm with you, someone.
Okay, thank you. So over to you. So meanwhile, as as he's preparing, get your devices ready, get your notes ready, and over to you, Silas.
All right. Thank you very much, Samuel, for the quick introduction. And also, for those that are here today, thank you for joining us here. So I'll be sharing my screen, and I'll try as much to come to the low level and explain. I'm not going to be so technical because I know we're just starting our journey in machine learning. And for those that have let's say prior knowledge, yeah, I'm still going just to try because of those that are just getting their way around things. So give me some seconds. So about 2 weeks ago, someone told me about this bootcamp that you guys are organizing some bootcamp on ML and AI. And I know we have a lot of people who are actually interested in machine learning. Uh, Considering the fact you guys have been seeing the boom in AI, I'm talking about the personal usage now. We use our ChatGPT, Gemini every day. Every one of us do that. You get so that sometimes that most of us don't even have to make use of Google anymore because Google will just link you to links of pages, but with ChatGPT you can like get around things easily in a fast manner. So how they come about ChatGPT is also as a result of advanced or sophisticated research that has been going on for years in this AI and ML. So before we deep dive into what we are doing today, yeah, I know most of us are just starting out, and I believe everyone here today we have basic knowledge of Python. Yeah, basic knowledge of Python is actually paramount if you are going into AI, and it's enough at least for a start. Because as you progress and go deeper by taking some courses or by learning on your own as well, you will get to know more about Python as well. But maybe after this whole session, my advice will always be you to learn on your own, maybe after taking some free courses, so you won't be lost in what we call tutorial. Because yeah, it does happen. I've been there as well before. So, but you just have to like make your way around things and learn on your own as much as you can. So, what we're basically doing today is just is classification. Yeah, classification is just one of the very small tasks in machine learning. And I know you guys have been working, you have been doing some interactive and technical session with some speakers so far. Yeah, I'm not the first person, and this is not your first class. So I want to confirm if everyone can hear me before going on.
Yeah, we can hear you.
Okay, good. So yeah, what is machine learning? A lot of people are knowing it. What is AI? We know what AI is. What is machine learning? So machine learning is the definition is very simple. It's just you teaching computer or machine. So me, I like using machine as an example because okay, we have machine learning. That is, you want a machine to learn. The machine there means just computer. Yes. So the computer can be your phone, it can be your can be an IoT device, it can be a laptop. It is just the computer in this case, or the machine in this case, or in this scenario means where this model are integrated. That's just what the machine means. So the machine can also be like a mobile app or a website. You do on your system, you prompt AI models like ChatGPT through website. Why on your phone, you also make use of them on your mobile apps. So that is what just machine means. So you just training a model without explicitly or explicitly programming them to do so. So I'm going to go back to about 60 to 100 years ago when it start this research about artificial intelligence. Artificial intelligence just basically mean mimicking the brain of a human. There are a lot of things really we human beings can do. A lot of things we can think, and from our thinking we can arrive at a conclusion to make a decision. And after making a particular decision, we can take action based on our own decision. So that is what humans are, because we know we humans we are very daring, are very curious about things. So we're like, how about we create something that can behave just as we are? Yeah, God created us, but how about we create something that is man-made? Artificial, yes, man-made. It is not created by God, it's created and orchestrated by us, the human. So that is how they come about everything. And artificial intelligence is the broad time term that is covering everything. So under artificial intelligence, we have what we know as machine learning that have previously defined for us. So under machine learning as well, we have deep learning, and deep learning is just like a subset of machine learning. Under this deep learning, so everything I'm listing now are they don't. There's one thing I would like you guys to put your mind at. There are a lot of technical terms they use in this machine learning field. Don't be bothered about it, because when you find out by searching it on your net, or just by reading books or by reading an article, you'll find out that these terms are not
Hello, Silas, are you there? We can't hear you anymore. Can anyone hear me? Can anyone confirm if you can hear me? All right, so let's wait for him. I guess it's his network.
um strong. Hello guys, can you still hear
Yeah,
me?
we can hear you now. We lost you for some seconds.
Yes, it was my network. Sorry. Please give me some seconds. I'm back. Yeah, sorry for the interruption. It's about to rain here, so they might take on the light anytime soon. So I have to grab my car and we are not going to experience any interruption. So as I was saying, I think I stopped at explaining deep learning. So these all these terms, you don't have to like bother about it until you just like search them, get to the foundation, to the root. You'll be like, oh, this is what they're talking about. So other deep learning, well, I think deep learning started gaining traction around 2000s. That was when they found out about deep learning. So when deep learning came out, there's something called large language models, like LLMs. So that the LLMs are like our ChatGPT, Gemini, and so on. those type of models that we interact with using natural language. So LLM is also a subset under deep learning. So you can see how everything is formed. So LLM started coming up. I think that should be though they call it language modeling before, because they were just trying to model language to see if a model can understand the intent and structure of a language, how we converse. There are some tones I'm going to like or converse or discuss with you, then we humans we can like grab it, but machines can't. So they call it language modeling before because they're trying to see how they can make models understand languages. Okay. So how they brought about the large there was because the model is very, very, very big, about billions of parameters. So that's how they mean large, okay, large language models. And that started coming up. The research has been going on, let's say, like close to 10 years now. But about, I think, 2017, something which came out, a very great work that led to the likes of ChatGPT and what we're using today. So there are a lot of research that are like that have gone through in here. And trust me, you don't need to like learn all these things. But try as much as you can to know the foundations, because this ML workflow, machine learning workflows, are still the same thing they are using to train these present LLMs. Because machine learning workflows deals with data collection. Don't worry, I'm still going to go back and explain all that very well as I progress. So I'm just giving an overview before we go in. So machine learning workflow involves data collection. So training LLMs also involve them collecting data, clean data. How do they collect data? By us scraping the internet, collecting our data that's in the internet. There are some blogs I have written like 2 years ago. There are some blogs most of you must have written like a year ago. Those data are what they use to train these large language models. They will clean it thoroughly and ensure this data of good quality before they can use it to train these models. So you can imagine everything, if you can truly understand the fundamental and foundational steps in machine learning, that is just the same thing they are applying. Just that, as things goes on or as days passes, we are going to experience some advancement. So it's just there are just a little advancement made, but the foundation cannot be ignored. So which is one of the reasons that if you truly want to become an AI engineer, then I will always, or ML engineer, I will always encourage people to go through these foundational steps. Yeah, you can become AI engineer by you just making use of APIs that these model providers like OpenAI, Anthropic, Google have provided. Yeah, you can do that, but you're not going to understand how these things are done. How do they come about it? The only thing you just have to do is just collect the API, connect it, use it to build a particular chatbot. What you only did there is just like plug and play. But if you are interested, okay, in going down the rabbit hole to understand things, yeah, this is actually like a good guy. So now let's go. I've already explained what machine learning is. So let's continue with what I have here today. So we have different types of machine learning. So we have what is known as supervised learning, the unsupervised learning, and the enforcement learning. So I think we have one more, but let me just reduce the scope to this, because what we are actually doing today is supervised learning. There was a time, I think that should be like 4 years ago, when you were working with large language models, they make use of supervised learning to train these models as well. So you can see how important these foundations are in this field. So it's not just one thing one can just ignore. But I can assure you that if you truly want to like go through this all this foundation, 3 months to 6 months is actually fine now with the type of technology we have today. You can leverage AI to learn. Anything you're not understanding, you can give it to AI to explain to you. And also consult relevant articles you see on the internet. So now we have supervised learning, unsupervised learning, and enforcement learning. Enforcement learning and unsupervised learning are actually outside of this scope, but I just included them here to make you guys aware of this. So enforcement learning just means you training an agent. The agents are the model, right? So Let's visualize this example. Let's say I have a dog. The dog is my pet. I have a dog as pet. Then if the dog does something that is commendable, I'm going to reward it by giving it a bone. But if the dog does something very bad, what are you going to do to the dog? You are going to beat the dog. So that is how reinforcement learning is. That is learning by taking actions that will earn you reward. So that is how reinforcement learning is. And reinforcement learning are applied in robotics and autonomous driving and other related applications. While for unsupervised learning, they are like word and opposites. Supervised learning, from the supervised learning means you guiding the learning. That's just like a basic explanation of what supervised learning means. While unsupervised learning means you are not involved in the training, in the learning of the model. Because so unsupervised learning now, this is how most blogs, books, most people define it. So unsupervised learning is you training the model with labels. So in machine learning, there's something we call labels. Labels are also known as target variables. That is the truth. The truth. That is, for example, now, let's say there are some features. Let's say I'm trying to train a machine learning model that can identify if a person, if this particular image is a boy or if this particular image is a girl. So after collecting some of the necessary features that can provide context if somebody is a boy or somebody is a girl. Let's say, for example, now we are actually being specific. Let's say, for example, there's a O in the girl's ear. They can say, yeah, this particular person is a girl. Most boys in Nigeria, we don't have O in our ears. Like we don't put on earrings, so we can say this particular person is a boy. Let's just use that basic distinction as an example. So supervised learning means you taking that features. Features here means the characteristics that this particular human being has O in his ear or does not have O in his ear. So if this particular person has O in his ear, then the label is what? That this person is a girl. If this person does not have O in his ear, that means this person is what? Is a boy. So supervised learning means you providing those labels. That is the truth, which is a boy, is a girl, and using it in training or during the training phase of the model. While unsupervised means you are not providing the label or the truth. That is, you're not providing if this person is a girl, is a boy, you're not providing those details. You are just giving it those features or characteristics that there's a role in the year. That is what unsupervised learning is. So, are you guys still with me? Okay, good. So, let's move on. So now, like I said earlier, what we are working on is what supervised learning. That is what we are doing today. So, unsupervised learning, we have a lot of steps under it as well. Clustering, like K-mix clustering. We also have dimension reduction. Dimension reduction. There's sometimes that we make use of unsupervised learning in some supervised learning tasks. When that dimension reduction now comes in when you are trying to reduce the number of features in the data set. So in case you come across this in your learning, yeah, that is literally what it means. And we have associatable learning. But for classic supervised learning, we have just two types under it, which are one is classification and the other one is regression. Today we'll be working with the classification model. We are working towards building a classification machine learning model. So what is a regression machine learning model? A regression machine learning model is very, very, very simple. They are just models that we have been taught statistics now. Okay, for those maybe that are still in your first year or second year. So let me just come down a little bit and provide an explanation. So regression here means the label varies. It can be from 0 to 1 million. It can be for 0 to 100. It can be for 0 to any particular number. That is what the regression is. So, for example, if you are trying to predict the price of a car, get it at the back of your mind that at this early stage, what machine learning is prediction. Machine learning is basically prediction. Even the large language models we are working with, the goal behind it was let us build a language model that can predict the next word For example, the cat is going there. You want to build a model that can where you give it this sentence D, the model will be able to know that the next word should come after will be what cat. Then we have the cat. When you give the model the model should be able to know that the next word that will come after the cat is what is the cat is that was the initial goal behind large language models. But after training and everything, they notice some behaviors that they didn't expect it to do, and they notice this thing performed well. So from there, you can see how interesting things are. So that is just how machine learning is. This word prediction. So for regression tasks, if look yes, for regression tasks, it means the variables are continuous. They vary. They can be from any number. They can be 10.5. They can be 100.5. That is predicting the price of the car. Example, let's be the model that can predict the price of the house. Let's predict the number that can predict the price of something, and so on. So anytime you are working with a machine learning model, you look at you don't just watch. There's some problems that don't need the machine learning. If they are rule based, if this, do this, you don't need machine learning. You don't need to use machine learning for them. Not all problems like that need machine learning. But if you are working with the machine, okay, you want to pick the machine learning model, look at the problem first. What are we doing here? Okay, when you read through the documents provided or the problem statement, you be okay, what are we trying to predict here in this case? Are we predicting the continuous variable? At first, your this thing that should come should start from this tree, this supervised learning. Is it a supervised learning task or your unsupervised learning task? If labels, the truth are provided, that means it's the what supervised learning task. But if they are not provided, it's the what unsupervised learning task. So let's say we have confirmed it's an unsupervised learning task now. Okay, what type of unsupervised learning task it is? We have two types of supervised learning tasks. So is the label or truth continuous or is it discrete? Discrete can take up a particular number. It can be 0 and 1. It can be 0, 1, 2, 3. But you can never see any discrete number that just varies. No, discrete are not made to be like that. I hope we all get this understanding. I just want to confirm if you guys are still with me. So if it's continuous variable or if it is continuous variable, you go for what? Regression. It's a regression task. There's no second thought or doubt about it. If it's a classification problem, does the label or truth involves two types of things, a girl and a boy? This image is a cat or a dog. Okay, what other examples can I wrap my head about? Okay, are we trying to predict if this model is an ox, a donkey, and a cow? This is also a classification task because it's discrete. You are able to count them. You get 1, 2, 3. If it is continuous, you can't count them. Do you want to? Let's say you are counting from 0 to 100. For example, that's what we are counting, right? Maybe like, yeah, I can count from 0 to 100 now. Okay, now from 0 to 1, we have a lot of number between it. Do you know that? If I'm going from 0.00001, 0.0002, 0.000, look at that. A lot of floating numbers are in there. So if it is a word, all those type of problem, just know that you are working with a regression task. So now, the tax we are working with today, I know this is classification you have seen above here is a kind of cheating because I've provided the context already. So now, let me go to the problem statement. I'm still going to come back to all this place. So the problem definition was that, yeah, you can see what I said. Start every machine learning project by clearly defining what you are trying to predict, why it matters, and how you will measure the sources. So for this project we are working on, the goal is to classify a flower into one of the 3 species based on 4 measurements. Based on means based on the characteristics of 4 different measurements. 4 measurements here means 4 future variables, 4 characteristics, 4 different characteristics. And the label here is what the species. So this data consists of about 3 species. When we are performing some exploratory data analysis, you'll be able to see some of the species this particular data set covered. Don't worry, anytime you're working with a particular data, they will provide some metadata for the data set. Because if you are not, only if you are not involved in the data collection, yeah, they should provide that. Because how can you work with a particular data set or business, solve a particular business problem if you don't have enough context of what you are doing? So they'll provide what they want to do. So these problems can be research problems, can be business problems. You can help Glow, MTN, or anybody to just like solve their problems. So depending on what they want to do, how they want to measure their success. Good. So now, so the problem here is that a botanist consulted, let's assume somebody called, so my network got interrupted. Sorry for that. So let's continue from where we stop. So let's assume everyone on this call, we are a machine learning team. Then a botanist or group of botanists or researchers that are into plant preparation and all consulted our team that they would like to automate the process of plant identification. That is, they want to automate, they want to build a machine learning model to automate that process, whereby they don't have to go through manual subjective processes. And these manual subjective processes can also be time consuming as well. So they want to eliminate this problem. It's a problem. If a task is time consuming, it's taking a whole lot of time. Not only time, and some other resources. It could be money, it could be a lot of other resources you can like wrap your head around now with me. So they want to try to eliminate those those resources and maximize them in some other places that is required. So this is the problem they want us to solve for them. How to automate the process so that they won't have their botanists trying to spend time on how to like identify or classify these plants. So they want us to do that. That is by giving us the measurement, the pattern and the sample measurement. So we could be able to build a model for them that can predict the species and iris is just by taking in those measurements. So you get, so that is what they want to do. So the species in this data set now that they provided us with is Setosa, vesicola, and virginica. So we have just three labels here that they want us to predict. That thing you are predicting is the label. If you are dealing with supervised learning, as I said earlier, what you are predicting is what is the label. So the label is about three here, right? As you can see on my screen, just look at my arrow. You can see we have Satusa, Vesicola, Color, and Virginica. Those are just the three species they want us to work on. So it is very straightforward. I know other supervised learning. We have just two types, which are the classification and regression. So what type of tax is this? Is it a classification tax or a regression tax? I'm trying to
Class-
question to any of us. So you can unmute and speak.
Classification
Classification. Why is it anyone to
because we just have
wait, don't
three
tell us. Don't tell us. Let's hear from other person. So we can see maybe everybody is with us. So anybody,
Yeah, it's a classification.
why is it a classification problem or a
You were
classification?
given three species, so you want your model to be able to classify whether this iris, your any given iris plant is either one of those three species.
Very good. It's very strict and direct. If we are given a particular problem that about to predict a continuous variable, that is what a regression tax. But yeah, just three. You should predict this, or predict this. Very straightforward. So now, other classification, they did not make the sub division here, which is not shown here. But have that back of your mind that other classification, we have either binary classification or multi classification. Binary classification simply means binary, from the word binary, it means either 0 or 1. That is two types. Let's say if we were given to just classify Setosa and Virginica, that's the binary classification tax. But since the classification or classes in this data set are more than two, if they are starting from 3 to about 10, that means is what type of tax is that? The multi classification. So in this particular problem, we'll be solving the multi classification tax. So and they made it explicitly clear here that they want their sources metric to be accuracy. Accuracy are used for evaluation. We are still going to go there. So they want it to be greater than 90% on the what test set. So that is what they want to see if the model is performing well, so they can automate that process. Immediately this model has been built, they immediately we are going to bundle it. So the bundling means you just converting into APIs and all. So tomorrow we'll continue with that. So after you doing that for them, they'll be able to what make use of it by means of what web app. They'll be able to communicate with your machine that you have built. What the machine here means that the machine is just predicting this the type of species a given flower is. That is what the machine is basically doing here. Like your ChatGPT now, it can write anything for you, summarize, perform machine translation tasks, that is perform language translation from English to Spanish. It can do that for you. So yeah. So now so you can see this machine learning for classification tags now. After we have read the problem statement and we have tried to understand what we're trying to do, and I believe everyone in this call is on the same page with me. So after we already know the type of classes it is, in the exploratory data analysis, data processing, we'll talk about data from balanced data set and imbalanced data set. We'll talk about that. This accuracy you are seeing here, precision, recall, F beta can be F1 score, it can be F2 score. Those all these are evaluation metric to test the performance of your model. Accuracy is not enough when you're working with classification tags. Accuracy is just telling you this or this. It's not going to tell you or inform you the subtle performance of your model. But with the help of evaluation metrics such as precision, recall, F1 score, ROC curve, AUC curve, precision recall curve, and so on. All these evaluation metrics are going to like inform you about performance of the model. Your accuracy might be telling you is 90. Then you go on with your precision. Your precision will inform you that it's 70. Then that means you still have a lot of work to get. So when you're working with binary classification tags, when you're working with um multi-classification tags, always have that back in your mind that accuracy is not enough. It's not enough. So you should be able to try to wrap your head around things and know the metric that is important in these tags we are predicting. When we are going, as we are going down, we'll get to know some of the metric between, most times, it's always between precision and recall. That is very paramount for this project. Each and paramount for this project, as I said, means for different projects we'll be working on. Let's say in the future, it could be application in healthcare, it could be application in space. We must think to know the type of metric that is highly important, highly valuable in that field. You can't just say, "Oh, I think precision is all right," since we have known that accuracy is not enough. No, we must think that why is precision enough? Why is recall important in this case? Recall important in this scenario, or precision important in this scenario does not mean the other is not important. No, don't get me wrong. But we are always holding one more, like it placing it higher than the other. For example, if I'm having my call should be like 89%, and I'm having my position should be like 93%. If it's a task where I want my position, or my position is the most important, then I'm having position of 93%, the call of 87%. That's a very good model. But if I'm having 67% of precision, I'm having 87% of recall, and precision is what I actually need for this particular task, then I'll still need to what? Train the model. Machine learning, AI, large language modeling, anything you want to call it, is an iterative process. Google, OpenAI, they are burning GPUs every day. They might be conducting some research we are not aware about. Until they notice some improvements in their model, they will inform the general public using technical reports. So they are always going back and forth to train this model. They will train at first, it may not give them um desired achievements on different benchmark. Or after we evaluate this model now, we are seeing something like 60%. We are not okay with that. We still need something better. We think, do some research. What can you improve this work? What techniques can help you to improve this work? You go back again to the drawing board. You plan, think, then again you try those other techniques. Then you'll be surprised. Your media performance can just skyrocket to 90%. But like that skyrocket to 90%, you'll be like, how did this just happen? You'll be able to understand why is this happening. Though you may not be able to fully understand why is this happening, but you know that okay, hope what I did is correct. Hope how I plug in everything is correct. So it won't be like it's a case of that data leakage, because data leakage is just you exposing the training data to be the test data. So when you're not testing with it, you're not testing with the data that the model has seen before. So the model will definitely perform well on it. So just have to be sure. Hope is not this, hope is not that. So machine learning, get back in reminder, machine learning is an integrative and experimentation work. You will there are sometimes that I've trained model for a particular task, it can be more than 20 times, it can be more than this, because I'm not getting like the desired the score like 80%. I'm getting like 75. I'm still thinking, how can I? If you let's say you are always joining hackathons like on Kaggle or on any public leaderboard, you will see your scores there. Let's say you have 75, then the top position is having about 76. Like, what can I do to improve this model again to about 77? Just to surpass this third position so you can get to the second position. So it's an interactive process. And something that you won't believe that wow, this thing can give this model this type of performance, and you just say that these are what you did, these are what you did. If you go online when you're trying to work with projects, always do research before you just write new machine learning to code and all. Code is not just everything. Do what are the existing research in this area already? What did they do to do this type of performance? So just do those research by reading articles. You will definitely get to see them. So now, flowchart of the machine learning model. How is a machine learning model created? So the workflow. Workflow is basically problem statements, which we have done. Then move on to the data collection. But in this case, they provided the problem statement. They also provided the data collection, the data for us. Data have been collected because I'm like a computer engineer or a computer scientist that does machine learning. You don't expect me to be able to collect data sets for plants. I don't have a domain expertise in that area. So they have provided that for us. Then the work now is for us to start from data processing. Then we can choose any model we want. Don't worry, there are a lot of models you can choose from. A lot. We have a lot of models. Don't worry, when we get there, I'm going to like lead mention for some of them. Then after you choosing your model, you train those models you have chosen, you train them. After training them, you perform some cross validation. I'm going to explain what cross validation is as well. Then after performing cross validation, if that particular model perform well on that cross validation you have executed or you have done, and it's exceed or fulfill or meet the training goal, yeah, we are good to go. If our goal was the model to have 90 accuracy, as they said, then what I did, the model I trained was about 91%. Then I'm good to go. You can now go on to what deployment stage. Any machine learning model you have must be deployed. That's just it. It must be deployed. Because who are you doing it for? You can't any machine learning model that is just in the on your Jupyter notebook or Google Colab just for you. So no use like that. Nobody can use your model. Then why are you doing the model? Maybe for learning sake, yeah. So always try anytime you work on machine learning model, you should try to just deploy. Even though you don't write a lot of code, just try to deploy. From there you learn more. That was why I went to the idea that okay, tomorrow we can go on with the what model deployment. But if at this place, this decision, this foresight, this thing, I've forgotten the is it kite? It means decision on this thing, right? If the training goal has been made, yes, deployment. If it was no, we go back. Sometimes we might go back to the problem statement. And at back of my mind, there's no one way for machine learning. There's no one way for it. And three of us, three machine learning experts might be given a problem to solve. The way I'll be tackle will be different from how that guy will tackle it. But the end goal is what? Fulfilling the what? Fulfilling the project goal. The project goal, this project goal is actually too narrow because you guys are just coming up. Some project goal can be the accuracy should be 80%, should be more than 80%, or at least 80%. Should the size should not be too much. That is here now. You are trying to what maximize resources. So a lot of people can train model, then they will check the model. Your model can be 90%. When my model is 85%, then when they check and perform analysis on it, they saw that my model is still more resources efficient. They'll go with my own because it exceeds the 80% accuracy and it's also resources efficient. While for the other person, it's the model is about 90% or more than 90%, then it's too large. So just okay, let's just eliminate this and just go with this person. Yeah, that result the person achieve, yeah, is commendable, but you should know that this machine learning, we just be machine learning models, we be machine learning models with goals, business goals in mind. If you are solving business problems, if you are solving research problem, research goals in mind. Now, if you are very current, you see how I saw is it 2 days ago or today that Google just find how they can make use of memory, maybe to make them very compact, but very small. So it won't take a lot of storage. So you can see those are like things they also consider as well because anything that takes storage requires money. If you want to change your laptop to 64 GB, is it ROM here? RAM, you know how much you will spend. If you are upgrading your ROM from 256, you know how much you will spend. So all these requirements, so one must check why building machine learning models. So depending on your goal, but yeah, we're just going straight forward. You get so if the goal of the training goal was not met, you might go back to problem statement to check is the problem from our data that we collected. That is, we'll go back to this data collection. Why sometimes at first the first thing is just for you to perform parameter tuning. Parameter tuning is same thing as hyper parameter tuning. So I just got these images from the internet, the sources on the internet, so I can like explain what I mean. So perform hyperparameter tuning. That's what we do. So hyperparameter tuning, when we get to model selection, I'm going to explain this as well. So that is just how the flow of machine learning workflow is. So are you guys still with me? All right. So let's go down to what which we want to do now. So now we all know we are trying to work with machine learning models. There are some existing machine learning frameworks already that we have. Some scikit-learn, you must use NumPy if you're working with this type of problem. You must use pandas. Pandas are just for the data frame, data manipulation, data wrangling. That is what pandas are for. Even NumPy as well. Why scikit-learn is a machine learning framework for traditional machine learning models. Traditional machine learning models in this case just means it's same thing as machine learning models, but the world has evolved. It gets so now we have sophisticated models like large language model and deep neural networks now. You get so that's why I just named them. They name them traditional machine learning models. So when you're working with them, I imported my matplotlib here and Seaborn for visualization. You can see starting from about I think 7th or 8th line. It is all scikit-learn. SQLN, 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 because we are making use of SQLN. It's a machine learning or traditional machine learning framework. So I think if you search SQLN here, you see it. They have a documentation you can read. All these things, uh, they are written in Python, and they are mathematics. Everything is mathematics. So you can, if you are interested in going down the rabbit hole to understand the mathematics, yeah, you are free to do that. It's his choice to get. So, but I will just, what I can advise you to do is, you can understand the machine learning, the mathematical concept behind logistic regression. That is going to like open your eyes a lot. There's this course by I think is it deep learning or machine learning by Andrew NG, one big man like that in this AI field. You can take that course. It will help you and open your eyes a lot. Even and for decision tree is just if elif else model. That's how a decision tree is. Don't worry. Down when we are getting to the down of this model book, you will see all that. And I all this model here now, I have understanding about everything here. So KNN to just understand how it works. You might not learn the deep down mathematics, but understand why it works this way. Read it, just go online. Everything about KNN. There are a lot of blogs that have been written 10 years ago, 5 years ago. You see them 5 years ago, these are the models that were booming. But most people now know the world has advanced. Everybody's impressed by what LLM is doing. That's why a lot of people want to come to AI. But nobody wants to pass through this traditional machine learning process to get. So, and if you understand the traditional machine learning process, you can't have that depth like somebody that have understanding. So you can just understand how KNN is. That is K nearest neighbor. That is what it means. So that's a classification model as well. And sklearn also have its regression variant as well. So you can read through sklearn documentation. If you don't understand the copy it paste to ChatGPT, explain to me. I'm going to explain to you. Whether you learn, then as you grow, as you grow, as you go, you start reading papers, start reading articles, then understanding your own. That's just it. Because you are just new to this. Any time you don't understand, just upload ChatGPT. We explain to you. So we loaded our or imported our libraries. I believe everyone here have a strong knowledge of Python. If you want to go into machine learning, knowledge of basic Python is very important. For loops, we rarely use while loop, but yeah, while loop is very important. You must understand loops, understand data structures, the use of dictionaries to store for temporary storage, so you can work with some things. File handling as well, because you're going to save your model as a file. You are going to load them as a file. So file handling, you must understand it too. And OOP, object oriented programming, you must understand it too, because when you start writing machine learning models, you will start using class to write them. And the thing when you're working with a machine learning model, if you go to yeah, I'm just trying to like introduce you guys to this. So I pick 3 models, but in a real world project, we might be using 10 models at the same time, training 10 models at the same time. It can be 5 models at the same time. 5 strong models for the task. It can be deep learning models and XGBoost, random forest, and so on. Random forest, XGBoost, decision tree, they fall under the same family, just as lion, cat, fox, and all falls under the same family tree. That's how XGBoost, random forest, decision tree, they are all tree-based algorithms. You can read about them. Very, very straightforward. So let's go down. Let's go on. So we have collected the data. It has been collected by the botanist, and it has been given to us. So now, the first thing you do is what? You load the data. If I was working with a custom-made data set, this data set was loaded from scikit-learn. You can see load iris. You see some scikit-learn. This data set they have written in the words in the Python framework. So if you have a good knowledge of OOP, this from import is not a problem. If you have good knowledge of OOP and function programming, it's not a problem because you will understand how classes work. You get a class is created to do something. I can write a class that we perform addition, subtraction for a particular after taking a particular input. So that is what they just did there. Each classes are providing one thing. This class is now decision tree classifier. It's providing what the decision tree model, so you can train with it. This logistic is doing the same thing. This standard scaler. Standard scaler is for data normalization, standardizing your data set so they can be on the same scale. Yeah, there was not like feature scaling here. I think okay, we added it to be part of the data pre-processing. So let's go on. So when we know the data set now, you can see the data set that we have. They give us SPE length, SPE width, pattern length, pattern width, and species. The species is the label. That is what make this problem a supervised learning task. The other features, we call them features, characteristics, because they are what describe that particular label. Just as we explained before, using the typical example of a boy and a girl. If I want to know you are a boy, most boy does not. Let's exclude boys that don't have young O in their year. If I want to know you are a boy, I look at the year. There's some characteristics you look at. You know this person is a boy. You know, there's some characteristics you look at. This person is a girl. So that is what this SPE length, SPE width is. That is what botanists actually use. They look at, they perform analysis by taking the length, the width, and everything to come to what infer that what decision to guide that decision that this particular species, Setosa, particular species is Virginica, and so on. But now they want a machine learning model to do that for them because see, look at an example here. Let me go down here. See the SPE width of this Virginica 2.8. See the SPE of this one 3.2. Very close. Even this one is 3.1, this one is 3.0. Very close. How am I going to be informed like that? It's a manual task. You have to be careful so you won't what misclassify. And you're not only being careful, you're wasting time because when you are being too meticulous about things, you'll be wasting time because you want to make mistakes. That is why they need a machine learning model that can do this for them. So what you should do first is just if I decide to change this to 10 now, it's going to list the first 10 rows. Let me run the script. So I'm going to it have to connect first. So it will load the 10 first row in the data set. The reason I have to load again randomly here, this dev.sample means random loading. So you can, if it's 5 you want, you change it to 5. They are all in the documentation of pandas you get. So the reason I have to do this because I noticed that when I was working with data sets, I was trying to prepare something, then I noticed that Setosa was the one if I list the first 50 now, if I change this 10 to 50, to be Setosa up to 50. So that's why I have to perform random sampling. So you can also know that this data set consists of versicolor, Setosa, and Virginica, just as they are provided us with in the beginning. So now let's get ahead. So after okay, we know what features our data set are. This is it. But we still don't understand many of them. We still don't understand it. We just know that yeah, it has these particular features and it is made up of this particular species. Then I perform all these are just data manipulation means you manipulating data to achieve a goal. This what I'm trying to do now is what I'm exploring the data. Trying to exploration means you're trying to understand what this particular data is using the word help of a tool. The tool here is what is Python. So if you can understand, the thing is just understand what you need to explore. What do you need to explore here? You want to compute the mean, you want to compute the standard deviation. Then with the help of a tool, the tool there as well is Python. It's how you calculate mean. It's how Python mean function is. Mean is what average of the numbers considered in the calculation or computation. Why standard deviation too is what you have square root of variance. That's how it is. There's nothing new. Don't look at it because it's machine. No, that's just basic mathematics. When you continue to go deeper, you get to that basic mathematics you are being taught in your probability. ChatGPT is based on probability. That is the mathematics underlying it. Very simple mathematics around it. Based on probability, then you get to know So now, then Python and pandas help me to what provide a tool that will lead me what in the exploration. So the Iris data set now I was able to know that this Iris data set it consists of 150 rows. This is a very small data set. When you're working with the population data, it can be 1 million data set. And the larger they get, the um larger the stress and difficulty is you get. So you can see how strenuous this type of task is. So yeah, for experimentation purpose, I have to like use the rest of 150. But when you get to work with messy data that tested your ability, then you get to that, oh, this place are not just easy as that because you have to iterate. You perform a particular this. That's why you get to the machine learning is truly an iterative process. Some data sets, that's why I would like when you're trying to when you want to know more, try to test yourself by training some messy data sets. This data set is very, very, very straightforward. Then you'll be like, yeah, I know machine learning, yeah. But when you get to see some data set that are like very, very, very messy, that will test your ability. Like, okay, are you truly a data scientist? Then that's when, or a machine learning, that's when you know, oh, you need to go back. And that is what will open your eyes to what I mean by machine learning is an experimentation task. There's nothing or no two-way explanation about it. You might perform one particular method, then yeah, you are good to go. So very, 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 very fast then you are correct, you have achieved what you want. Why sometimes they don't go that way. So you have to iterate, try this other process and all. So Setosa, I went forward by saying, okay, since this consists of 150 rules, that's 150 samples, we have seen that the number of columns is 5 now. From here, one, this one and this index are not counted. 1, 2, 3, 4, 5. So I went further like, okay, how many the species we are working with, Setosa, Virginica, and Versicolor. How many samples do they have? They have 50 samples, 15 samples, 50 samples, which is what makes 150 samples. And here we are having everything is balanced. But in real data set, like in Sean prediction, in automate financial systems, yeah, Sean prediction financial system that is predicting a loan. This your loan, this you are seeing on your fintech apps such as OPay, Money Points. They make use of they can use machine learning for their prediction. I don't know what is the back end of their system, but I believe since how the work is sophisticated now, they should use something like that and not some rule-based system anymore. So this is what is going down under the hood that you're not aware of. But they are not balanced. Now I told you earlier that I'm going to explain what balanced data set is and the balanced data set is. This in this case is a balanced data set, but in reward solutions. Because in most transactions, what happens? There are always cases of is not this transaction. Okay, now for example of fraud detection, in most data sets we have, or most cases we have in reality, we know that each sample or rows should be made of a case that is not a fraud case. So you can see how imbalanced this data set is going to be. Because when I'm transacting using my OPay or money points, I'm not doing any from fraudulent activity. So you should just go. So when they collect all this old data, you can imagine how many fraudulent activity we present in data. It can be 10%, while the other 90% are what? Non-fraudulent activity. You can see how imbalanced this type of data set is. And this is what also makes it messy because your model will be provided 90% of data set that is not fraudulent. That means your model have high capability of predicting or classifying a particular transaction or flagging it as what non fraudulent, whereas it might be fraudulent. So you can see how one can be needs to be very, very careful in the design of ML systems. You can actually like have a feel of that. Or if you are working with churn prediction, churn means I should cancel my subscription. That is I think that's what churn means. Yes. Most times, most people are not canceling that subscription. But when they cancel that subscription, it's based on some things. Maybe they're not longer enjoying it. For me to subscribe to X, YouTube, it's because okay, yeah, on my YouTube, I don't want to be seeing ads anymore. Or for your Spotify, most of us here we subscribe to Spotify. Okay, I don't want to see ads anymore. I want to be able to have a playlist. I want to be able to play song anytime, any day. That is one of the reasons we are what subscribing to Spotify. But let's say in a case, then you just decide that, okay, oh, you don't subscribe anymore. For you not to subscribe anymore, there's a reason for that. So in most cases of that data set now, if that data set is given to machine learning or data scientists to work on, it will consist of people that subscribe, that assist that subscribe to the products and less of people that what defer us that subscription. That is what Sean means here. So you can see how imbalanced that data set will be. So you want have to be very, very careful because this process is a very straightforward one. That's why you see that I'm not doing some advanced techniques once you apply. So for handling imbalance and balanced data sets, you can use techniques such as smooth. Smooth is I think synthetic oversampling technique. I think that should be what smooth means. That should be what smooth means. Yeah, okay, synthetic minority oversampling technique. So these are like techniques they use in what handling these cases if it occurs. So let's move on. So all these are just like normal data manipulation steps. So you have to like you can read notebooks as well. People that they have done all this work, you can read note, go on cargo, want to learn about this, they read about them, practice with time, you get better. Or even though you get exposed, get by just stretching yourself, you get better. That's just how I also became acquainted and familiar with all these things. It doesn't start from one day, you get. So sample by class, we all know that each species consists of 50 samples. I turn Setosa to 0. You can see the map that I did there. Versicolor to 1 and Virginica to 2 because machines, computer that we want to train don't understand English. They work with numbers. You get so we have to convert them to numbers, numerical variables. That's why I did the word the conversion. So that is it. Your ChatGPT, all those I am a boy, let's go, let's move here, let's move there. They performed some tokenization that converted that natural language into numbers before they can train the model. Your computer will not understand English and so on. So these are the same thing here. You can see how they transfer a little technique in this machine learning workflow to what training models, large language models. So exploratory data analysis. So exploratory data analysis is just for one purpose to understand your data before touching a model or training series of ML models. The reason you can see I use before touching a model, it can be one if you are doing for experimentation or series of models. In production, you have to like use your model and compare and see the one that is performing best in terms of accuracy score, precision, and also in terms of costs. Cost is there as well resources. So it guides ML engineer and data scientists to search for patterns, to understand distribution, correlation, and any potential issue. That's why if perform a very great exploratory data analysis, EDA for short, if you perform it, it will drive or inform you on how you design your ML system. And it can also inform you on what is guiding your model to perform a particular description or prediction rather. That's what it does. Further in guiding engineers on how to train the model for optimal, effective, and efficient solution, best or what optimal for best or optimal performance. So all these perform statistics. See, Python is a very programming language, so you don't have to be writing all this again. Before, when they started, they have to be writing performing what sum by plusing. You have asked to perform 2 plus 2 plus 2 plus 2, you have to add them together. But with this dot sum method, you can just perform your addition. That's why I said learn OOP, then explore this thing, these libraries, pandas, numpy, scikit-learn. You see that it's very, very, very easy And they are what that normal or basic mathematics that you are familiar with. Some you are familiar with some. Everyone here is familiar with C mean here. So all these libraries will help you with it, so accelerate the process and just get you the work. Particular derivation here, they are all what you know. And the maximum means the biggest number in this particular features. Sepal length is 7.9. The smallest is 4.3. So you can see, even looking at this table, one should be able to see the distribution of it. Well, let's continue. So now I perform some data visualization. Anyone that is in green is setosa, orange is what vesicular, and this other color is virginica. When I look at for the sepal length, the features, you should notice, you should be able to like see some differences. That is, species setosa have shorter sepal length. See where it is there. See the highest here. Why species vesicular has what? Especially is sepal length is a bit higher than that of setosa. So these are the things EDA open your eyes to see. If you are using your hand to do this thing, you can't see all this. You can never see it. But with the help of EDA help was to perform visualization with the help of what? Python packages like Seaborn and Matplotlib. So you can also spend time to learn Seaborn and Matplotlib. Okay, yeah. He said this is the peer plot the former instructor, previous instructor made mention of. So this is EDA will help you, will inform you on how this what data is already, what is in this data. You can't just go on and be running and building model. No, that is failure. Even though your model works well, but in reality, you can't. If you don't prepare your model well, the model will perform totally bad. And if your model does that in production, you guys, your company is wasting money and you are killing lives. Yes, because an engineer, if you are building a model and you're trying to integrate into an IoT device that can perform heart disease prediction, then you do not do EDA, you do not do any core machine learning technique, you just went to build a machine learning model, you
Hello,
hide
Silas, I
the
think your
truth from
network is
everybody
breaking
that
up.
your model is performing well. The model end up with this thing and somebody is free or is does not.
I can hear you, but I think it's
You have
breaking
to
like every 2 seconds or so.
let me pay for my now. How about now?
Hopefully, it's better now. You can continue first.
For that particular scenario I'm talking about now, the model ended up with this thing, that a patient does not have heart disease. They ask the patient have heart disease. So you can see what that will result to. So especially in healthcare, you have to be very, very, very careful because it is a safety critical application. That's how we are applying ML to. And in financial systems as well. You have to be very, very careful. But if you are building a model around customer money, then just the model is not performing well, then you just need to make some prediction. And the model ended up doing some nasty shit on some things that will end up or make the customer ended up losing their money. That's a what? A bad image for the company. So you can see like these are like what they do before what is designing national system. So this idea is going to help you. Guys, let's look at the correlation heat map. So correlation heat map, now sometimes like, if I'm working with very large features, I think there was one place I did that, like we have a very large features, maybe about 20, and I'm even trying to maximize not only storage, yes, and also see how I can improve the model by considering just few features. Though we have neural networks that can take in 100 features, don't worry, yes, they are available. But sometimes I just need to try so you can optimize. So how can you use heatmap? Heatmap just need correlation. You know correlation. Correlation is just we have positive correlation, it can be negative, but it must not be above one and it must not be below -1. That is must be within the range of -1 to 1. You get correlation is in statistics, and I'm very sure the number of us we have heard about correlation, either in 100 level your first year. So that's just correlation. You can see how important this mathematics and all is there. They are basic mathematics you are aware of. But if you can just read, you get to see that how basic they are. So correlation, look at this 1.0 is because separate length is on the x here, it's also on the right here. That's why it's 1.0. If you look at this one to separate width, it's still the same thing. So you don't look at that. So you move to the other one between separate length. If first one is for separate length and separate width, you can see the correlation very, very small. I have no problem with that. If I'm working with the large data set, I have no problem with that because they are not related. Correlation means they are related. But being related does not mean castration. There's a very popular quote like that. There's a way they put it. I can't remember like that, but that is what it means, that because they are related does not mean that particular feature is contributing to that. No, it does not mean that. But you can just, like I said, machine learning is like an experimental work task. So I can just try to say, okay, because these features are having correlation coefficient to be more than 0.8, let me take one out of it. For example, 0.87 here between separate length and beta length. I can decide that let me use only separate length to train the model and see the performance. That is if you're having a very large features. But here we're having just how many features? 1, 2, 3, 1, 2, 3, 4. This species name, don't bother about it again because it's your label. I'm not even meant to put it here, but because I converted from Setosa to 0, Setosa to 0, Virginica to 1. So Virginica to 1. So that's all what I did. So let's go on. So you can see this feature distribution. Feature distribution is with box plots. So box plot means this arrow at the center means the mean. This one means the minimum. No, this one here means the minimum. This one also this means the maximum of that distribution. So this one is showing for this. What I did here, I had to group them by their species. That's if I check the code now, you see I group them by what? By their species. Look for blocks plots. You see, I group them by their species here. So that is those are that is this separate length consists of 3 species now. Can be Setosa, vesicola, group each one with a distribution. So that's what I did here. So here we have all these number outside this box are called outliers. But outliers here are not important because since the distribution of samples are very, very small. If I'm working with about 10,000, 20,000, like I don't mind disregarding or removing some features. But yeah, if I remove any features, I will be damaging my model. My model will not have enough data or samples to be trained on, and data sets is very important when I work with machine learning model. So I just have to consider them. Okay. And sometimes before I move away from here, if I don't want to group by spreadsheet, I just want it to show. It's going to show 4. It's going to consider everything here as 1. Everything here as 1. Everything here as 1. Everything here as 1. This one I told you not to mind this species name. You know, it's not in the numerical form, and that's why it's showing here. If not, it's not making sense. So we're going to have 4. Then you can check if there's an outlier there. Then later on, you can go down to group just like the outlier, just for you to group them and see. So is if I'm working with a big data set, big messy data set, you might spend days or months on exploratory data analysis. But there are a lot of things to explore. Some business problem does not just want you to build models for them. They want you to answer some problems, they want you to answer some questions. Why is this like this? So for you to get why it's doing like this, you have to perform exploratory data analysis. So everything else is about building models. If you work as a data scientist, machine learning engineer sometimes. So there are a lot of things that just go down. But yeah, we're just working the straightforward method. So as I said earlier, standard scalar is for data standardization for you to ensure that all model, all features considered in this training set are on the same. I'm coming. I want to show you something. Are on the same scale. I want to show you something. Okay. So I have to. So before, there's one thing we have to ensure when you're working with that I want to standardize your data. You can choose any set. Yeah, I choose 80 for the train, 20 for the test. Test set here means 0.2, 20%. If I want 70% for the train, 30% for the test, I'll go to 0.3 like this. Yeah, let's just put that 0.2. Because this data set is very small. 0.2 times 150. Is that not 30? So we have that 30 data set and we're training with 120. Am I right? Yeah, we're training like 120. You can see how small the data set for training is. So let's just leave it that way. So after, and always ensure that you perform splitting before standardizing your features. If you don't do that, I mentioned earlier that something we call data leakage. You already give some context to the data set or introduce, you have already provided some context to the text data set on how your training data set is. So when the model is predicting on that data set, it will be like no surprise to him because I've seen this type of data set before. Then as you predict them well, then to you, will be like when the model predicts well, it will improve the accuracy or any metric you're trying to beat. Then you'll be like, yeah, my model is performing well. So I also learned the hard way too. So that was when I knew that you have to what? Split first before performing with standard skill. So standard skill is just normalization. If I search it, what is mean? It's still like what is your status? That's just class. That's just class. Very, very, very strict. You can see what is in your mathematics. That this is what the future, this is the mean, this is the standard deviation. Because it's very, very, very straightforward. Or the name they will call it, what is this? What is this thing? They want one big technique. Then this fit transform just means okay, we'll take this training data that are these features to the training data. Because I splitted, that's why I name it. This train split from circuit length was return 4 values: train of x and train features of x. No, train the features training data and the testing features as well. Why for this y as well? Label of the training set and label of the testing set. That's the 4 things to provide when you pass in your features and your labels. Yeah, I drop. I don't even know any of you noticed. I dropped it here. See, I'm trying to find where I drop it. Okay, this is where I drop it. I'm going. You can see this the drop is to drop a particular. So like I said earlier, species is the setosa, but species name I converted to 0 and 1 because machine don't understand that English. So I have to drop the 2 of them because I don't need it in the features. What I need, I just use 4. Right? Let me run this. Then let me print X. It will only consist of those 4. You see, let me just put X so you can see it. So it will be neater. You see, so it consists of 1, 2, 3, 4. Only the features we want to use. Then Y now consists of okay setosa because the reason here is because some model, transfer machine learning model can accept this. They will undo the conversion to 0, 1. Python has they have added that to the Python package. But most times, if it was me, I would just if like the potential setting, I would just like convert to 0 and 1 to be ensure on the right path. So now this data set, let me go back. Look at it too. You can see the set length for all this 5.1. Standard scale now will convert it to another thing by ensuring that everything are on the same scale. So that one feature, because the reason you have to perform this thing is that look at peta length. Most of it are always 1.55. Look at separate weights, for example now. Let's go to our distribution. Statistical summary. Look at the mean of separate weight. That is, most of the values are roughly 3 at the range of 3. Most of the value of sepal length are at the range of what? 5. So if I don't scale my this thing, my sepal length might be contributing to the prediction of my model compared to how this sepal width is. And what gave you the assurance that sepal length should be contributing more to the performance, to the prediction of the model? Nothing. We want to ensure each features have the same power in the prediction. So which is the reason we are scaling. That is the primary reason for scaling. So we're not giving more feature, more power, because you don't know it as well. It's a machine that is learning this thing using some mathematics, known formula, statistics, probability. It's a machine that is learning. It's not cheap. You get, but we are just the one orchestrating the whole process with your intuition and your understanding. So let me try to print this scale. This fit just means, okay, after I've already instantiate, because yes, it's instantiate because the class instantiate this, then one of the method is fit transform. Fit by what? Convert this train, this one, by standardizing it to a format that everything will be on the same scale. Does not mean on the same scale does not mean they will have 2 they will not they are not going to, let's say if I'm using mean scalar, this one, minimal scalar is another variant of standard scalar. Mean scalar means they must not go beyond 0 and 1. That is, will not pass that range. For this standard scalar now, it might be the range of, we can't really tell, it can be the range of, because it depends on your mean and standard deviation. You can see before this thing I went to, when I search it, you can see the formula x minus your mean over your standard deviation. So we can't really tell. So it depends on how big your mean is. So it's going to ensure that everything is on the same scale. So now let me run this. So you see how it's having some negative values, but ensuring that at least compared to how it is there, then 5, this one is 6, this one is this. Everything you rarely see anyone that is more than 2 here. You rarely see. So this is still very good enough. So sometimes you can go with standard scalar, why sometimes you can go with mean scalar, and mean scalar might give you the good results compared to standard scalar in some scenario. Why sometimes standard scalar will give you a good result. So it's like you can't tell. So you have to experiment with a whole lot of what options. So now, after I'm ready to process my data, processing means ensuring your data is ready to be used for training. Here, I did not look at data training or data cleaning because our data is not dead. Messy data sets, we go through the data cleaning process. Data cleaning process, I'll try to be fast now because I have just 20 minutes left. So the data cleaning process means eliminating missing numbers if there exist in your data set. I think I computed for missing numbers there. See, missing numbers, they're all 0, 0, 0. That there's no missing numbers here. Just use dot is not dot sum to provide the missing number for you. So that is how you will check. Okay, our model is clean, no missing number. You will also check it is not, but okay, hope sepal length is not having anything like a categorical feature when it is meant to be a numerical feature like 6, 7. Hope is not having boy in that particular section. You will check all these things, so you can see how exhaustive this whole process and tying and born this whole process is. So that is what you want to ensure your data are in good state before you are training anything. You want to just ensure. And sometimes that your categorical data, instead of leave data are very, very messy because some users on websites I just enter instead of boy, they will enter boys. Why? Let's say you have 20 people, 5 people enter boys. Then the real thing to enter was boy that they read, but they enter boys. So we have 15 people that entered boy. But you as this, you are just training it. You just consider everything to be boy. We have 15 boy, and people entered 5 people entered the form as 5 boys. So you consider that still need to work convert that 5 boys by removing the X. Python can help you to do that using regex or any very simple. You can even ask ChatGPT for the solution to come up with it and use it for what you want to do. Convert boy. Okay, you can just search for it because of time. So convert that boys to boys because everything must be on the same this thing before you can go ahead. So if everything is now with that boy, then you cannot go ahead. That is for categorical variables. Most of the variables we consider here are numerical variables in our futures. Sepal length, sepal width, petal width, they are categorical, or they are numerical because they can consist of any values from zero to and so on. But for categorical variables, they can either be boy, girl, they can either be dancing, standing, sitting, and so on. Model training now. So let's train it logistics machine learning model. I instantiate it. After instantiating it, I call dot fit. Dot fit is okay, train this particular model based on the training data. You can name it anything you want to name it. Yeah, I'm following what I've named it with before. After processing the data, standard scalar. So then after I fit it, it's ready training. Let me see where I stop from. So this thing will not go there. So after I ready, you can see how fast is it. Using it fast because this data is small. If it is large, it will be slow. Still be running for you, like, or you can leverage CPU to make things faster. So after training the model, fit here means train. You perform prediction using the train model. Let me perform by the words using the test set you have kept. No, we divided the data set into train and test. 80% training, 20% testing. So you now predict based on the test set, then that will give you your prediction. After, you now, from the beginning of this discussion, I've explained why accuracy is not enough. That's why I consider other metric like precision. Don't worry, all this they are very simple formula. The core score is just, I think it's 2 times precision and record. That is it. So let us start with this formula. These formulas are TN, TP. TN means true negative, TP means true positive. They are very simple things. So you can see it's divide and addition. That's what makes up the formula. So you can read this. Tomorrow we're going to continue from deployment. I'm going to go back to this evaluation and just talk about it before I go to deployment. Because I should have more time tomorrow because I'm trying to meet the deadline by 7 now. So you can just read this after the call. Just wrap your head about it. If you are just seeing it, if you have seen this before, yeah, that's also good. So you can see, then I perform my course is multi classification because I use weighted. And this weighted is good for imbalance classification. But yeah, it is balanced. Everything is all 50-50-50. And that's what made it 150 samples. If it's for the cases of fraudulent data, like I mentioned earlier, or shown prediction data sets, all these are very important. Even while you have already used those smooth technique. So take note of what thing I've mentioned. Smooth, synthetic minority oversampling technique. You can apply that on your imbalance data set. Then you can apply undersampling and also oversampling. Then for your prediction, for your evaluation, you can also apply weighted. Yeah. Normally, this score should be in the range of 0 to 1. So because I want everything to be in percentage, I have to like multiply by 100%. So all these are just normal Python print statements. So output for output. Then there's also a contribution matrix. Contribution matrix will just show you, it will help you to visualize. Precision is just giving you a score. Recall is giving you a score. But how the formula came forth for precision is from this contribution matrix. True positive, true negative, TP, just like you saw when I searched it. So I'm still going to come back to all this word tomorrow. So let me just branch things. So you can see your conversion matrix here now. Conversion matrix now is telling us that yeah, for this particular model, we have our model, our electricity model is predicting right for setosa. That is, see setosa here is 10. We have 10 for each. No, it's not misclassifying setosa as any other flower or species. No, it's 0. But when you look at versicolor, instead of 10, it's predicting versicolor, the real one should be 9, while misclassifying one of it to be what Virginica. So you can see. But what did this actually a fear model. Considering the fact that the data is not much. And for one, also seriously
Hello, Silas. If you can hear me, your network is breaking again.
Virginica too,
Hello, can anyone hear
same
me?
thing happens. So this one was also positive. Why is it coming like true?
Yeah, but your
Yeah,
network
can you
is
hear me?
breaking.
Wow.
Also, the time, you mentioned something about time before.
Yeah. By before 7 hours,
All
meeting is by
right.
7. So
So you can carry on.
so if you want, I wrote the everything I have to write it in a class. If I converted everything to a class use of that particular, I intend to turn into somebody who wants to use as well with time, yeah. So that's why I said knowledge of work is very, very important. So here I consider taking model because in production you can be considering about 10, 5 models. So this will make it very easy because you're running 4 loops. You're running 4 loops. So chain everything, after chaining everything, collect the model details, perform. See, this does fit. See the same thing that is there. Yeah, but yeah, I did it. You can see this one is what models. I should not be right. I should logistic like how I did this for the logistic regression. I should write them one after the other. That's not possible. So groups to just do that. Instead of writing these 10 times, you're writing it one time because of group cases. You always use this. So it's very, very go on. I can send you a private thing. Not be that important to this concept. Well, as you go on, you will notice that writing code is just simple as doing software engineering. You are going through, you are working through an algorithm that if this does this. If you check some open source code repository on GitHub, that is how everything literally works. So knowledge of DSA is very, very important. It might not teach you well in school. Though the person that taught me there taught us a bit well, but they might not teach you well in school, but the resources online. Even me, I'm going back to implement those DSA and writing them what because they will help you what might be an interview or anything as well, or how you write code as well. So you also help because they deal with data structure, storage of the data, the writing, and how the flow of an algorithm should be. You can also use loop to write my results. For the logistic regression, I've seen here 93.3, it's the same thing as here. Parameter tuning, like I said earlier, can be parameter tuning are all these max iteration. For logistic regression is what max iteration. This random state just means I want to be able to reproduce this experiment. If I change it to 66, it will give me another result because machine learning is a call it is it stochastic? Yes, stochastic process. Random is at random. It is not deterministic at all. So we have to use random states because I'm working with scikit-learn to ensure that when I load this notebook again, I'm still going to be getting 93, 93. If I change, let me even change it. Let me try to go on this. Let us just see. Maybe it will change. You see, it changed. If you notice, this wasn't 96 before. Let me show you this wasn't 96 before. See, this was how my notebook was before. Everything was 93, 93, 94. But now it changed. It changed what? So you can see how those random states also have an effect here. But don't worry, you can just perform randomly. So it's an iterative process, but ensure your whole machine learning process are intact, very intact. So that is the result. It's posting everything out. This for the decision tree model. You see the accuracy improve and everything. So perform cross validation. Cross validation is actually there. Just you perform validation across a course of the data. For example, you can divide data into 5 cross validation. Yeah, that's what I did. Perform cross validation. Yeah. Then am I scoring that it should be but should take highly time notice of the accuracy. That's what I did for simple implementation. It can be precision, recall, and anyone you want. Share the documentation. You see all the information you need there. Okay, once perform a cross validation by splitting into 5. It can be 10 depending on how big your data set is. So yeah, I split to 10 to 5. So that is group 1, group 2, group 3, group 4, group 5. In this first group, you are saying this first part here should be for test food. The remaining should be for train food. Second group, you are saying this middle one like this should be for test. The one you do is test. The other one should be for train. Here and here will be for train. So the third group, because you can see how everything is. So you now after doing that, you use this train food for the training, then this test for the testing. You will perform what we know as your scores, accuracy, precision, and all. You go again to group 2. You will do the same thing. Isolate this part, train on this, then perform prediction on this, or evaluation on this. Then go to the third group, fourth group, and so on. Then after, that means we'll be having about 5 different scoring across the whole groups. Group 1 will have its own scoring, group 2 will have its own scoring, group 3, group 4, and group 5. They will not perform an average. Average is just plus everything together divided by 5. That's what they are doing. Then under this chrome light color is known as the train fold. Train fold acts validation fold and internal training fold. Because in machine learning, we work with training fold, validation fold, and testing fold. Training fold is to train the model. Validation is to perform validation based on the model during the training process to inform you, while the training is usually for testing the performance of the model. The model you have coded, let us test it. It has not seen that data before. Okay? So that's what cross validation simply means. So yeah, I just did a plot of cross validation that is, as I said earlier, into 5 groups or 5 folds. That is, it's the same thing. For fold 1, look, let me take a look at logistic regression. Okay. Decision tree. Decision tree already covered the logistic regression column. Decision tree. It was 96. The reason your score can never be more than 100. I use 105 so that you can see everything. If I use 100, it's going to cut it off, even though it actually 100. So that's why I use 105. So you can see this one was at 96. Decision tree for the first food. Second food was also at 96. Third food was also at 96. Fourth food, it went out to 93. This one also went out to 93. Look at for KNN. For 96, it went to 100. It went back to 96 for the second food. So you can see, so conversation will also help you to see how the model is performed across different folds of the data. So if you are having something like 90%, you are good to go. So we are having 60, they went down to 40, 30, then no, you should go back to the drawing board and go through the end workflow again. So model evaluation, I've said that before. Model evaluation is what we did with the help of accuracy, precision, recall, and so on. So this one is just what I did here. Option matrix. But yeah, now I'm working with a lot of models. So I have to do the option matrix for the whole model. This thing is going to change now. It scores because I changed the random states. It changed before, it was 9-1 and it has changed. So that is all. This one just plotting. You are plotting. If you are presenting to stakeholders, you are not presenting from a down the street. You put everything in slide So this graph are what I'll be presenting to them, that this is how my model is performing as a prototype before they can now, okay, let's go with a model, let's implement it, let's deploy it. Then these are what are going in the back end, in money points, in OPay, complaint, for financial system application, MA financial system application. These are what are going on in the back end before they will now integrate into an app anyone can use. So they will test it, go through series of processes and so on. Then model influence. Model influence just means I want to make use of my model. That's what model influence means. I want to see. I've already trained. I'm okay with my results. My results is giving some 97%, 93%. Yeah, good to go. Now let us perform influence on it. That is using the chain model to make predictions. That's meaning of influence. So yeah, now I'm just putting any number 6.8. I'm not putting any number. What I did doing this is that I searched for, I said list characteristics of the column by let's say by and so on. So that's what I did actually. Then I copied this thing, then I just put it here. So it said the length is always like this. So that's what I did, and I just put it here. In tomorrow, when we are doing with the deployment, users will not be entering using Jupyter Notebook or command line using your VS Code. They'll be entering through a web app, like your form. When you go online, you're always required to fill the form, like Google form. So that's how you're going to collect the information. Then in the back end, the system will perform its own computation. After performing the own computation, then to return the type of predicted species. Is it Virginica? Is it this one? Is it this one? So you get, so that's how what influence means. Influence is not meant to be done on Jupyter Notebook actually. It's meant to be done either in a web app, either in an IoT device, either in a mobile app, or anywhere you want to integrate your model. That's where influence is meant to be done. But at least we just try it first in our Jupyter Notebook. Then we can now turn this into a function using Python dev. Let's see how to name it, make influence and so the model interpretability, like I said, it's just series of if statements. So because that sometimes similar interpretation is of paramount importance in financial systems and healthcare systems. Because nobody wants a model to perform any prediction that will cost the life of a patient. We don't want that type of model. Get so they don't just accept your model if it's doing 90%. No, they want to know how that your model is coming to a conclusion. Why is it performing this way? Why is it telling us this person has had this? Why is it telling us this person does not have? That is what that's what's going on in today's research. Though they have been able to accomplish some, and again they are also not able to accomplish some, but it's still an hotspot in the area of research, model interpretation. You want to understand. Even GPT, researchers don't understand how these models make their predictions. They don't really understand it, but they have some basic understanding on it. So model interpretation is a very important research, even model observability and so on. So as I said, this one tree is just if statement. If it is less than, you see. I converted the features using standard scalar so that it can be on the same scale, right? So if it is this, do this to come to this side. If it is this, it's setosa. So that is how model may make decision, especially for decision tree. That's why I have to use scikit-learn to bring out the decision tree. Though I'll share this notebook with you so you can learn. Just go through it. So this is another decision tree. This one is form of text. It's the same thing that is here. So decision tree is the same thing as if this, do this. If this, do this. That is the mathematical understanding or explanation behind decision trees. So you see, I'll be able to explain what decision tree is to you. So go and learn logistic regression, KNN. We have random forest. You see, we have a lot of selection algorithms. I think about 20. You have like GBM, a lot of them. And some projects, if classification, you make use of all of them. If you have made use of all of them like that, you know them because you have already read about them. So when you're using for another project, also make use of them if you like, and just experiment if this particular algorithm will perform well on this data. And if it doesn't, to scrape it out. That sometimes logistic equation can outperform XGBoost. So that sometimes XGBoost can outperform neural network when you're working with tabular data set. So it doesn't mean it's not a one-way method. You what learn by what by performing experiments. So model exporting, just exporting now. When you are done training our model, we have to export for production deployment, which we'll be doing tomorrow. So tomorrow I'm still going back to evaluation metrics. I'll brush through it, they'll go to deployment. So you have to what, save your model with open as five objects. That's the name of the FDF. So you can see how important file operations are. So you can see how important they are. So every basic knowledge of Python is very important. Very important. So now see in this introduction to machine learning bootcamp, we have explained and explored the complexity of traditional machine learning models. That is right from the problem formulation, which could involve the business problem or research problem, to what, model deployment. That is the goal. So tomorrow we'll finalize everything. And you can see from here it is apparently noticeable that knowledge of solid basic Python is highly instrumental here. Like I said earlier, these are for you data structures and so on. So go and solidify your Python knowledge, and everything does not come by a day. It's a whole lot of process by experimenting, learning, and doing a lot of things. And you get knowledge of OOP is great to have and is a must prerequisite for ML in the wide. ML in what I mean by in the wide is in the real world when you're applying it to real world problem. It's very important, even when you're practicing. Very important. Understand OOP. When you start working with neural network now, I mean, I'm almost running up. I have just 1 minute left. OOP, you have inheritance, polymorphism, abstraction. I think there are about 5 classes of OOP. You can see these and this. Okay, this is not even showing it. This is not showing what I want. This is not. Yeah, this is showing it. This one. So this is a thing from. It's not even showing what I want. There should be like some NN model from PyTorch. PyTorch is a deep neural network framework they use for your training of large language models. What they use. So you can see this is inheritance. So you can see how important these are. So go and solidify your OOP. The understanding of file operations using Python is important, relevant, file writing, reading, and saving. So this is a basic overview of how machine learning systems are trained or developed, and a strong foundational understanding of this workflow serve as a launchpad for understanding the sophisticated techniques training today, like the likes of LLM, vision models, and so on. So don't skip the fundamental process, read and try to explore as much as you can to stay grounded and updated. Staying grounded means you learning to understand how things really work. Then in the search of that, try to open down your eyes and your ear for news to stay updated with where the AI world is heading today. If this is a field you are interested in, because the field of ML and AI advances in a very fast manner, and comprehension of fundamentals is imperative as well. So I wish you. So this is just like a pattern which like your journey in ML should be very exciting and also of rough in the sense that in the form of you experimenting and getting things done. So thank you very much. So tomorrow we can continue. I'll have to leave now because I'm I need to join the meeting myself. So Samuel,
Yeah,
so
thank
that's
you
all.
very much.
Yeah, there's no problem. Anytime.
So let's
No,
give him a
Samuel,
round of.
what time tomorrow? Sorry.
We could do 6
Okay. Oh,
p.m.
I'm alright with 6.
All right.
Yeah,
Thank you
man.
very much for
All
joining
right.
in. Let's appreciate our speaker here. I think this is an interesting session, and you guys will get to find out the importance of this session like very soon. So for those of you that joined, thank you very much for joining. You will likely take something away from this session. Right, so we are going to meet tomorrow again. As you can see, there's a lot, and it didn't really go too deep. Right, so tomorrow we'll be focusing on deploying your ML applications. Now you understand why this is useful also later. Right, so just charge your devices for tomorrow, come with your notes, and get prepared. So please, can we meet earlier tomorrow? I don't know. We just concluded the time with the speaker now for 6. So what was the meet? It depends on other people actually. I could run a poll again, but I think most people will choose evening, and I think it's a good time because people would have been done with classes then, and maybe IT students would have gotten back.
This 6 p.m.